we are looking at finding volumes of three-dimensional figures with known cross sections. Okay, that may not make much sense right now, but I've got some visuals that hopefully will help understand what's going on. Okay, so it says use calculus to find the volume with the indicated base and slices. Show the integral used. All slices are perpendicular to the base. So on our first one, our base is x squared plus y squared equals 4. What is x squared plus y squared equals 4?
It's a circle.
It is a circle. What do I know about the circle?
I don't know. It's circular. It's got a radius.
Radius is
4.
2.
Radius of 2.
Dang.
Okay. And where is it centered?
At origin.
At the origin.
Whatever
Okay.
you use it, whatever's next to X.
So I've got this circle. It's got a radius of 2. It's centered at the origin. That is my base. Okay. On this base, it says we want to stick square slices on top of it. So we're going to stick a bunch of square slices on top of it, and that's going to make a three-dimensional figure. So
Square slices.
square slices is going to give me something that looks like this. And
What?
there's a three-dimensional figure. We can go around it. Okay.
Wow.
And I will show you that it is sitting on top of a circle. So I'm going to give you a view from the top.
Bottoms up.
So I'm going to give you a view from the top. When you see the view from the top, you can see that I've got a circle. Okay. Okay, and then I want to show you that the cross sections are x's or squares. So I'm going to come in from the left. Come in from the other side. And then I'm going to turn it, and you can see that it is a square. So I've got a bunch of squares sitting on top of a base that is a circle. That's what I've got here. Okay. So let me build it back up. So if I go back out to the right,
That is cool.
it gives me that. Go back out to the left. You get that figure.
That's cool.
So now you can see what the three-dimensional figure looks like.
I want something
Yes. So why? Courtney made a good observation there. Why is this thing taller in the middle than it is on the ends?
because you come out to a wider radius as you get towards the middle of the circle.
Because in the middle, yes, in the middle, what's happening to the sides of the squares in the middle?
They're getting longer.
They are the longest. And out towards the edge of my circle, what's going on with the sides?
Smart.
They're getting smaller. So that's why this thing is taller in the middle than it is on the edges. Because from top to bottom, out here on the edge, top to bottom is not a very long distance. And remember, a square, however big one side is, the other side has to be that tall. So in the middle, obviously, at the very middle, that's going to be the biggest square I can put in there. Okay? So can everybody understand visually what this thing looks like? I've got a base, and then I'm sticking a bunch of slices on top of it. Okay? So we want to use calculus to figure out the volume of this thing. Okay? But to do that, I want to go back and talk about finding the area of a circle without using the pi r squared. I want to find the area of a circle using calculus. So what do I need to be able to find the area of this circle using calculus? How do we find the area using calculus?
With the integral.
Integral.
Oh,
So we're going to integrate from where to where on this?
-2 to 2.
-2 to 2. Okay, and then I need to change this to where there is a top and where there is a bottom. Now this formula is x squared plus y squared equals 4. So what can I do to that to give me an equation for the top and an equation for the bottom?
1/2? No.
When we have equations, they're usually What do they usually look like?
Y equals
Y equals. So let's get this thing to be y equals. So what can I do to get this to be y equals?
subtract x squared and square root.
Subtract x squared and square root it. And I need a positive and a negative. Now, do you see my two equations?
Yeah.
Okay, the top part's going to be what?
Positive.
The positive square root. And the bottom part's going to be the negative square root. So now, I can finish up my integral. What needs to be inside of it?
The top minus the bottom.
Top minus the bottom. So the top minus the bottom. That would give me the area of that circle. Okay, but now I want to talk about what is this thing actually doing? What is that actually doing to be able to get the area?
You're going the area under the curve from the top all the way down, and then just keep it
Okay, let's talk about this middle part. What does this represent?
the circle. Area of the circle.
If I plug an x value, if I plug any x value in between -2 and 2 into this part right here, what would it give me?
Is that how high your square is?
Don't forget about the square right now. We're just talking about the
Value of
circle.
The value on the circumference.
The,
So let's say I wanted. Let's say I plugged. Let's say I
it'll
plugged.
hit the outside of the circle.
Let's say I plugged 1 into there. Okay. What is it going to give me if I plug 1 into here?
The top of the
What is this? What does this part represent?
up
The
to
top part of the circle. What does this part
the
represent?
bottom.
The bottom part of the circle. So if I plug 1 in there, what does the top minus the bottom give me?
0.
Right in the inside.
Doesn't it give me the distance from the top to the bottom at 1?
Yeah, maybe.
Because if I plug 1 in to the top, it's going to give me that y value. If I plug 1 in to the bottom, it's going to give me that y value. And what am I doing with each of these values?
It's an addition.
I'm subtracting them because this y value is
It's negative.
negative. So if I take a positive minus a negative, it gives me the distance between those two, right? Okay? So that's technically what we're doing to get the area. We're technically going in here and plugging in all these x values, getting all of these distances, and then what does the integral part do?
All of the x values in between the 2 points.
It gives me, it takes all of these distances right here and does what with them to get the area? Adds them up. Okay? So that's what this does. This right here represents the distance from the top to the bottom.
Everywhere in there.
Every one of these x values in here, that represents all of those. And then this integral right here takes all of those and adds them up. So when I have every distance in here, distance in here, that thing is going to be solid. And once that thing is solid and I add them all up, what does that give me?
The area.
That gives me the area. Okay? So again, what does this inside part represent?
The distance.
That represents the distance. Okay? And what am I doing to the distance?
Integrating.
Integrating it. So what happens when I integrate distance?
Get your area.
I'm going to get area. So answer this question for me. What happens when I integrate area?
Volume.
I'm going to get volume.
So we're just going to integrate it twice.
So I'm not going to integrate it twice.
Oh.
I need to integrate area.
Yeah, you're
So I'm going to
integrating
take I'm going to take these distances, but now instead of a distance, it is a
square.
square. So what do I need to know about my square?
How long is it? The area of this.
I need to know what's the area of each one of those squares. And if I know the area of each one of those squares and then I add it up, that gives me the volume.
Your square is just the
Square, what's the definition, what's the formula for area of a square?
Side square.
It's side squared. What does the top to the bottom represent?
Are you gonna double the area?
A side.
Oh, you're just gonna square.
So I'm just going to square. If I square the inside, then I have the formula on the inside that is what?
One side of the square.
That is area. The inside formula would be area, and then when I integrate area, I get volume. So that's what we're going to do to find volume of a solid with known cross sections. Okay, so first thing you need is the area formula for your cross sections. That's the first thing we need. We need the area formula for the cross sections. So if I'm dealing with squares, what is my area formula?
X squared.
Or side squared. Okay, I like side squared. So my area formula is side squared. Once I find my area formula, then I need to know
What S?
what S is.
S equals area base.
I need to know what S is. Okay? And if I'm dealing with a circle and I'm sticking squares on top of it, S is going to be what? S is always going to be a distance. And what's the distance always going to be? Top minus bottom. So my distance is going to be top minus bottom. So in this case, S is going to be the square root of 4 minus x squared minus the negative square root of 4 minus x squared. How can I simplify that though?
Squared.
And then just two of those? Okay, once I do that, then I plug
Yeah, that's right.
into the area formula. So now my area formula is going to be 2 square root of 4 minus x squared squared.
So 16 minus squared.
And then this represents area, and what do I do to area to get volume?
Right.
I'm going to integrate it from -2 to 2, and that gives me the volume of a bunch of squares stuck on top of this circle. That will give me the volume of that three-dimensional figure. So I need the area formula of my cross sections. I need to figure out what my variable is, which is going to be top minus bottom, some variation of top minus bottom. Plug that back into my area formula and integrate it. That's how we're going to find volumes of volumes of solids with known cross sections. Okay, so let's finish this one up. So -2 to 2. If I square that, it's going to be 4 times 4 minus x squared. So what can I do with this 4?
Integrate. Distribute it.
I can take it to the front.
Oh.
So let's take it out to the front, and then let's just integrate those two. So that would be 4x minus x cubed over 3 from -2 to 2. Plug in 2, that's going to be 8 minus 8/3. Plug in -2, that's going to be -8 plus 8/3. So this 8 is going to turn positive, so that's going to give me 16. This 8 is going to turn negative, so that's going to give me -16. 3 times 16 minus 16 is going to be 32. Which gives me 128 over 3. What does 128 over 3 represent?
The volume of the solid.
The volume of the solid that has a base that's circled and has a bunch of squares stuck on top of it. That's the volume of it right there. Okay? Let's move to the next one. Okay, the next one says the base is a triangle formed by the line y equals x, the x-axis, and x equals 3. So let me see where that one's at. There we go. So we have the line y equals x. We have the x-axis, and we have x equals 3. So there's my triangle that makes up my base. Now, what is it we're going to stick on top of this thing? We're going to stick semicircles on top of it. So if I stick semicircles on top of it, this is the figure we end up with.
Like a little
Half of it gone.
Okay, so I'm going to rotate it to where you can see that it's sitting on top of our triangle that we were dealing with. Okay, then I want to rotate it back the other way. And if you look through the end, you can see that it's made up of what? Semicircles. Okay, now let me... Let me animate it. So take some off of this end. Take some off of that end. And then rotate it, and you can see that it's made up of a bunch of slices that are semicircles. So does everybody visualize what's going on here? Okay. Now let's find the volume. So if I'm going to find volume, what's the first thing I need?
area.
I need the area formula. So what's my area formula that I need for this problem? 1/2 pi r squared. Everybody okay with that? So what variable is it that I need to find?
R.
I need to find r. So if I go back to my figure, okay, r is going to be what?
1/2 distance from the top to the bottom of the triangle.
It's going to be the distance from the top to the bottom. Distance from the top to the bottom, if you notice on this semicircle, what is the distance from the top to the bottom in relationship to the semicircle?
It's going to be the. I know
It's the diameter. Okay? So I need the radius, so what do I need to do to my diameter? I need to take it in half, take half of it. Okay? So what is the top part of my triangle?
Your x.
The x, and what's the bottom part?
X-axis.
The x-axis, which would just be 0. So the diameter is going to be x minus 0, which means the radius is going to be 1/2 x, or x over 2. Okay. This right here, whatever variable that is always going to be some form of top minus bottom. Sometimes it's just going to be top minus bottom, and that's it. Sometimes in this case, it's top minus bottom, and I've got to divide it by 2. Okay. All right. After I figure out what this is, what do I want to do?
Plug it in.
Plug it into my area formula. Okay. Once I plug it into my area formula, then what do I want to do?
Take that integrate.
I want to integrate it. And in this case, where do I want to integrate from?
0 to 3.
0 to 3. Any questions on the setup? Because the setup is the hard part of this problem. Everything else is stuff you've done before.
Oh, we can remove the 1/2 pi.
Let's move the 1/2 out, but what does this 2 underneath the x turn into? Does it turn into a 4 when I square it? So I've got a 4 and a 2, and take the pi out. Let's take a pi over 8 out. And that just leaves me with x squared in the inside. So we integrate x squared. So that's x cubed over 3 from 0 to 2.
You're integrating from 0 to 3.
0 to 3, thank you.
Oh.
0 to 3. So we plug in 3, that's 27 over 3, which is 9. I plug in 0, and that gives me 0, so we end up with 9 pi over 8. What does 9 pi over 8 represent?
Volume of
The volume of our three-dimensional figure. So the volume of that three-dimensional figure is 9 pi over 8. All right, next one.
You gave us a lot of room for this one.
Well, I was only going to do 3 examples, but we'll be able to get through this one and be able to do one more.
Yeah.
All right, this time our base is the enclosed area formed by y equals e to the x on the interval 0 to 3 and y equals 0. So remind me, what does y equals e to the x look like?
Something like.
Yeah, it's just that exponential that looks like that, correct?
And then you have y equals 0.
And y equals 0, what is y equals 0?
It's the long side. So
The x-axis. And it's between what and what?
0 to 3.
0 and 3. So here's 0, 1, 2, 3, there's 3.
The weird shape.
So that shape right there is our base. That's our base.
Squares on it.
And we're sticking squares on it. So what do I need to start with?
Area of
Area of the square. Area of the square is
side square.
side square.
Side is
So what's the next thing I need to find?
side.
What a side is. So I go back to this. What's the side going to be?
Top minus bottom.
Top minus bottom. The top is e to the x. The bottom is 0. So that means the side is e to the x. Once I find my side, what do I do? Plug it back in. So that is e to the x squared.
Multiply the exponent.
Yeah. So that is e to the 2x. And what do I want to do with e to the 2x? Integrate it from
0 to 3.
0 to 3. Okay, so e to the 2x integrated. What do I get when I integrate
E
that?
to 2x over 2.
E to the 2x, derivative of the exponent is 2. I need to divide by it, so I get 1/2. So I'm going to leave the 1/2 out here. I plug in the 3. That gives me e to the 6. What happens when I plug in 0?
You get 1 half.
You get one.
I get 1. And we're happy with leaving that as our answer. What does that represent?
Your volume.
The volume of that three-dimensional figure. That is correct. What do I know about the height of this three-dimensional figure as I move to the right?
It's
Larger.
getting bigger.
It's getting taller. Yes, that is correct.
It's getting
Because
exponentially taller.
the sides are getting taller. That is correct. All right, one more. And this one's not on your sheet. All right. It says our base is the triangle formed by the line y equals 2x minus 4, the x-axis and the y-axis. So, how can I graph 2x minus 4? What do you know about it? Goes through -4. It's got a slope of 2, so up 2 over 1, up 2 over 1. So it goes like that.
What's a right triangle?
We have the x-axis. We have the x-axis we're bounded by, and we have the y-axis that we're bounded by. So we are interested in that triangle right there. That's the base. Okay. Now let's talk about our slices. Our slices are rectangles where the height is twice the base. So what do I need to know about rectangles?
The area.
The area of rectangle. What's the area formula for a rectangle? Base times height. Okay.
It's twice the base.
So I know the height is what?
2b.
The height is 2b. So that means my area is 2b squared. So what do I need to find next? We need to find b. is B?
One distance.
Top
0
minus bottom. So 0 minus that, so it's going to end up being
negative 2x plus 4.
negative 2x plus 4 or 4 minus 2x. Everybody okay with that? Once I know what B is, then what do? Plug it back in. Then what?
Wait, do you have to multiply that out?
No. All right, so we're going to integrate this from where to where?
0 to 2.
0 to 2. Does everybody understand why it's 2? Everybody understand
2
why?
over 1 up to over 1.
Yeah, because I went up 2 over 1, up 2 over 1. So that means I went over 2. So that's why it's 0 to 2. And what can I do with this 2?
Pull it out.
Pull it out.
Wrote it down.
So 4 minus 2x parentheses squared dx. Okay, now I think Zach was asking, do I need to multiply this thing out?
No.
You can if you want to, but you don't have to. What can I do to integrate that?
Add 1 to
Integrate the
the
outside.
x bar.
Integrate the outside, that is correct.
Divided by the inside.
But I've got to make sure I do the derivative of the inside, which is
Negative 2.
negative 2, so that means I need to divide by negative 2. And I have that 2 out there.
Yeah, so it's just a negative.
So it's just a negative 0 to 2. So I'm going to pull the 3 out as well, make it negative 1/3, and then I'm just interested in plugging into the top. What happens when I plug in 2?
You get 0.
I get 0. Okay, when I plug in 0, that gives me 0. I need 4 cubed, which is 64. So we've got a negative and a negative, so we end up with a volume of 64 over 3. So it's not very difficult if you keep some things straight. What do we need to start with? Area formula. Then I need to find
With your variable.
the variable that's in the area formula. Once I find that variable,
Plug it in.
plug it back in, and then do what? Integrate, and there's your volume.
You
So
got
that's how you find volume of solids with known cross sections. Got it?